Hi guys, welcome back to my YouTube channel. Today we are going to discuss about the difference between DFA and NFA. In automata theory, four types of finite automata are used to recognize the regular language. Among these two are DFA and NFA. Both have the same function, but there are some differences in their structure and working. It is very essential for one to have a clear understanding of the difference between DFA and NFA for anyone to understand the computational model or to know how to design an algorithm. What is DFA? DFA refers to deterministic finite automaton. A finite automata is said to be deterministic if, corresponding to an input symbol, there is a single resultant state, that is, there is only one transition. A deterministic finite automaton is set of five tuples represented as Q in an empty finite set of states in finite control. Sigma, a non-empty finite set of input symbols. Tau, it is a transition function that takes two arguments, a statement and an input symbol. It returns a single state, Q naught. It is starting state, one of the states in the queue. F, it is a non-empty set of finite states or accepting states from the set of Q. NFA. What is NFA? NFA refers to non-deterministic finite automaton. A finite automaton is said to be non-deterministic if there is more than one possible transition from one state to the same input symbol. A non-deterministic finite automata is also a set of five tuples and represented as Q, sigma, tau, Q naught, and F. Q is a set of non-empty finite states and sigma a set of non-empty finite input symbols. So it is a transition function that takes a state from Q and an input symbol from and returns a subset of Q naught, initial state of NFA and a member of Q. F, a non-empty set of finite states and member of Q, or it can be told as a set of finite states which are accepting states from the queue. Difference between DFA and NFA. DFA stands for deterministic finite automata. NFA stands for non-deterministic finite automata. For each symbolic representation of alphabet, there is only one state transition in DFA. No need to specify how does the NFA react according to some symbol. DFA cannot use empty string transition. NFA can use empty string transition. DFA can be understood as one machine. NFA can be understood as multiple little machines computing at the same time. In DFA, the next possible state is distinctly set. In NFA, each pair of state and input symbol can have many possible states. DFA is more difficult to construct. NFA is easier to construct. DFA rejects the string in case it terminates in a state that is different from the accepting state. NFA rejects the string in the event of all branches dying or refusing the string. Time needed for executing an input string is less. Time needed for executing an input string is more. All DFAs are NFA. Not all NFA are DFA. DFA requires more space. NFA requires less space than DFA. Dead configuration is not allowed. Dead configuration is allowed. Example, if I give input as 0 and Q naught state, So we must give one as input to Q naught as self loop. If we give an input of 0 on Q naught state, so we can think we can give next input 1 in Q1 which will go to the next state. As a function, Q into sigma is equal to Q, that is next possible state belongs to Q. And in the NFA, Q into sigma union to 2 power Q, that is next possible state belongs to the power set of Q. Conversion of regular expression to DFA is difficult. Conversion of regular expression to NFA is simpler compared to DFA. Epsilon O is not allowed in DFA. Epsilon O is allowed in NFA. In DFA, there is only one possible transition for each input state. In NFA, there can be multiple transitions for single input for a given state. So, in conclusion, DFAs are deterministic, uncomplicated to implement, but they create greater automata, while NFAs are flexible and can less bulky but difficult to implement. In fact, despite these differences, NFAs and DFAs are powerful as each other in that they are able to recognize the same classes of language. It is possible to convert any NFA to a DFA, even though the amount of states in a resultant DFA can be more than the initial NFA. So this is it for the today's video, guys. I hope this video is helpful. So thanks for watching.